notes for lesson 4.3 part 2, using Cramer's rule to solve systems of equations. So if you remember from the last chapter, we talked about solving systems of equations, and the three methods that we used were graphing, substitution, and elimination. We can also use determinants and matrices to solve systems of equations, and one way to do that is using Cramer's rule, and that allows us to use the determinant to solve a system of linear equations. Now this rule is named after a Swiss mathematician, Gabriel Cramer, who came up with this method. So if you recall, a system of linear equations is two or more linear equations in this form here. Now notice that we have A, B, C, and D. Those are all numbers in front of the variables. If you recall, that is what we call a coefficient. So the coefficients are the numbers in front of the variable. And again, that is A, C, B, and D. The other thing we need to know to use Cramer's rule is E and F, and we call these constants because they have no variable. They're just numbers that stand by themselves. So what we need for Cramer's rule is to write the coefficient matrix, and that's the matrix formed only by the coefficients of x and y's, and they're found in standard form. So once our equations are in standard form, which they are here, we just take the coefficients in front of our variables and we put that into a matrix. So notice we have A and C are the coefficients of our x value. We have B and D, which are the coefficients of our y values. So we're going to use these things in Cramer's rule to solve a system of equations. So Cramer's rule we use for a 2 by 2 matrix, and that is if the determinant does not equal 0. The system has exactly one solution. And Cramer's rule says that our x value comes from the determinant of our constants and our y coefficients. So if we look here, E and F are going to be our constants. So to find our x value, we put our constants first. And our second column is consisted of our y coefficients. Then to find y, we first want to write our x coefficients, and our second column is our constants. So we're using the opposite coefficients of what we are solving for. And then that's all divided by the determinant of A. So for example, when we're solving the system using Cramer's rule, so the first thing we need to find is the determinant of A. So the determinant of A, we first need to set up our coefficient matrix. So our x values are going to be 2 and 3, our x coefficients. Our y coefficients are +1 and -2. So we need to find the determinant of this matrix. So again, we're going to cross multiply and subtract. So 2 times -2 minus 3 times 1 gives us -4 minus 3, which is -7. So the determinant of A is -7, so we're going to divide each of our determinants by -7. So now we need to find our x and our y values. So to find our x, we want to find the determinant of our constants first. So if we go back to our system of equations, our constants are the ones on the right-hand side of the equal sign. So we have 1 and -23. And then we need our y coefficients. So again, those are the coefficients in front of our y's. So it's going to be 1 and -2. And then remember, we divide this by -7. So to find our x value, we need to find the determinant of this matrix here. So 1 times -2 minus 1 times -23, which is just -23. Again, this is all over -7. So x equals -2. Subtracting a negative is the same as adding. So 23 minus 2 is essentially what we're doing, which is 21 divided by -7. 21 divided by -7 is -3. So our x value is -3. So then we're going to go back and solve for y. Again, if we look at our formula, we want our x coefficients listed first. So our x coefficients in this case are 2 and 3. And then we need our constants in our second row. So that's going to be 1 and negative 23. And again, this is all divided by negative 7. So if we define the determinant, again, we're going to cross multiply. So 2 times negative 23 minus 3 times 1. 2 times negative 23 is negative 46 minus 3, which is negative 49. Again, divided by negative 7 gives us 7. So y is equal to 7. So our solution for this system of equations is negative 3, 7. And again, we can check just like we did before by plugging it back into our system of equations, and we should get a true statement with both equations. We can also use Cramer's rule if we have a 3 by 3 matrix. Again, if the determinant of A does not equal 0, the system has exactly one solution. So again, just like before, here's our system of equations. Now we have added one more variable and one more equation. So the solution is similar to a 2 by 2. We're just adding in that third dimension. So for our x, our first row this time is going to be our constants. Our second row, B, E, and H, are our y coefficients. And our last column, C, F, and I, are our z coefficients. And again, that's divided by the determinant of A. To find our y value, our first row is our x coefficients. Our second row is our constants. And our third row is our z. Our first column is our x values. Second column is y values. Third column is our constants. And you'll notice that for whatever variable we are solving for, that's the column that our constants go in. So for x, our first column is our constants. For y, our second column is our constants. For z, our third column is our constants. So the constants take the place of the variable that we are solving for. And again, we find the determinant of A and we divide by that first. So example 2, we're solving this other system, this three-dimensional system using Cramer's rule as well. So again, the first thing we need to do is find the determinant of A. So we're going to set up our matrix. Again, we first need to start with our x coefficients. So that makes up our first column. So that's 3, 2, and 5. Our second column is our y coefficients. So 2, negative 1, and negative 3. And our last one is 4, 3, and 5. Now if you remember, to find the determinant of this 3 by 3 matrix, we want to rewrite our first two columns. So 3, 2, and 5, 2, negative 1, and 3. So we have our first diagonal. 3 times 5 is 15, times negative 1 is negative 15. 2 times 3 is 6, times 5 is 30. 4 times 2 is 8, times negative 3 is negative 24. We're subtracting from that. 4 times 5 is 20, times negative 1 is negative 20. Plus 3 times 3 is 9, times negative 3 is negative 27. Plus 2 times 2 is 4, times 5 is 20. If we add all these up, we get negative 9 minus 27, which equals a positive 18. So the determinant of A is 18. So that's what we're going to divide everything by. Next, we're going to solve for x. So here, we first take our constants. That makes up our first column. So 11, 4, and negative 1. Then we need the y's. So 2, negative 1, and negative 3. And our z's, 4, 3, and 5. Again, we're dividing that by positive 18. So to find the determinant, again, we're going to rewrite our columns. So 11, 4, negative 1. 2, -1, -3. So if we start with our first diagonal, we have 11 times -1 times 5, which is -55. 2 times 3 times -1, which is -6. 4 times 4 times -3, which is -48, minus, opposite diagonal, -1 times -1 is +1, times 4 is +4. 11 times 3 times -3 is -99, and 2 times 4 times 5 is a +40. Again, if we simplify, we get -109 plus 55. Again, still all over 18. That equals -54 over 18. So our x value is -3. Then we're going to go on and solve for y. So again, the first column is our x values, so 3, 2, and 5. Second column is our constants, 11, 4, and -1. And last column is z's, so 4, 3, and 5. Again, all of this is over 18. We're going to find the determinant, so 3, 2, 5, 11, 4, -1. 3 times 4 times 5 is 60. 11 times 3 times 5 is 165. 4 times 2 times -1 is -8. And we're going to subtract the opposite diagonal, so 4 times 4 times 5 is 80. Plus 3 times 3 times -1 is -9. 11 times 2 times 5 is 110. Simplify that, we get 217 minus 181, again all over 18, and that equals 36 over 18. So y equals 2. And lastly, we solve for z. Same thing, x values first, so 3, 2, and 5. Y values 2, -1, and -3. And then our constants, 11, 4, and -1. Again, all over 18. So rewrite those first two columns and then find the diagonals. 3 times -1 times -1 is a +3. 2 times 4 times 5 is 40. 11 times 2 times -3 is -66. Minus, opposite diagonal, 11 times -1 times 5 is -55. 3 times 4 times -3 is -36. And 2 times 2 times -1 is -4. So if we simplify that, we get a -23 plus 95, again over 18. That equals 72 over 18, which equals 4. So z equals 4. So our final solution, -3, 2, and 4. So again, we could solve systems of equations using graphing, substitution, or elimination, and this is just one other way that we can solve systems of equations using Cramer's rule.